Hello, my name is Gabriel Smith. I am representing RT Alderman. Thank you for coming to review my science fair project called the Pond Skipper. In this project, an old technology called the Acronoplan is merged with new plasma technology to solve a new world issue. Problem. Currently, large ships of all types transport our goods. Although they are the most efficient, this mode of moving goods produces high levels of greenhouse gases. When ship and plane emissions are combined, the modes of transportation I intend to provide a solution for, they total upwards of 5.5% of total greenhouse gas emissions each year, which is equivalent to 1.86 billion metric tons. Hypothesis. If a vehicle could be designed that doesn't produce greenhouse gases while moving vast quantities of consumer goods as well as people over a near infinite distance, the transportation industry could be revolutionized and the pace of climate change could be slowed. This could be achieved by combining the Acronoplan with plasma technology. What is an Acronoplan, also known as a screen glider? In aviation, there is a phenomenon known as the ground effect. This effect occurs when an aircraft flies close to the ground or is landing. When an aircraft performs this maneuver, air is compressed under it, creating a sort of cushion. This cushion of air wants to decompress, but it can't push downward due to the ground, so it pushes the plane up, generating lift. This puts less of a strain on the motors working to keep the craft airborne. The Acronoplan harnesses the ground effect to create a highly efficient form of travel with a high cargo capacity. Plasma power. Migrated sensor. Plasma reactor concept. A plasma reactor will be used to power the systems, subsystems, and motors of the proposed vehicle. The reactor produces power by heating water to steam, which in turn creates electricity through a steam turbine. What is plasma? Plasma is a superheated matter that rips electrons from atoms, forming an ionizing gas. This makes it the fourth state of matter due to the fact it's got no fixed shape or volume. Plasma is an array of electrons, and there are so many that they rub together, generating friction and heat. Because this is happening constantly, the heat of plasma is brought up to 11,000 degrees Celsius. Pond Skipper. The Pond Skipper is a variation of the Acronoplan. The original designers of the Acronoplan figured out that size affects stability while flying in the ground effect. The larger a vehicle is, the more stable it will become. Because of this phenomenon, the Pond Skipper is twice the size of the Lund class and completely independent from fossil fuels because of the plasma reactor. How it would function. The Pond Skipper is intended to land mid-flight multiple times to refuel. This is because water is used as a fuel source to generate power and to sustain the reactor. An intake mounted on the belly of the Pond Skipper will collect water by using the momentum remaining by the Pond Skipper gliding to the water. The Pond Skipper will then take off again, hence the name Pond Skipper. The time intervals between each landing is unknown, as consumption rates can't currently be calculated. Materials. The 3D design software called Tinkercad was used to create a visual representation of the Pond Skipper. This model was then printed through the use of an Ender 3 V2 Neo 3D printer and PLA resin filament due to its moderate strength while being readily available. Here's the design process with a few images and the final design here. The final printed design serves as a visual representation on what the Pond Skipper could look like. Solving issues of the past, part 1. Turning radius is an issue that plagued the larger models of the Acronoplans, such as the Lund and KM classes. I intend to solve these issues through the use of thrust vectoring and rudder surface area. Large flat sheets will be attached to each side of the prop's exhaust. These sheets can be tilted to direct the exhaust flow, which boosts turning speed. An example of thrust vectoring can be seen on the British Harrier jet aircraft. Unlike the larger classes of Acronoplan, the Pond Skipper will have two rudders located in a similar way to the Ukrainian Antonov AN-225 Miria cargo plane. This will increase rudder surface area, which boosts turning speed. Solving issues of the past, part 2. Salt water intaking was the second issue that became apparent on larger econoplans. This could be solved in 2 ways. The first option is creating a guard that prevents updrafted water from entering the intake and prevents the engine from intaking in that direction. However, this decreases the efficiency of the propeller engines due to the fact intaking from that direction is blocked. A second option is using more corrosion-resistant materials such as titanium. This also has a disadvantage, however, related to cost. To buy a pound of titanium, the cost is 35 cents, which is much higher than stainless steel at 6 cents per pound as of right now. Cost. An estimated cost, I compared the pond skipper's dimensions to the base Boeing 737. The Boeing 737 has a price tag of around 120 million Canadian dollars and has a length of 40 meters. The pond skipper has a length of 148 meters. Therefore, the estimated cost, excluding extra flight instruments required in an econoplane, is around $445 million. This price is similar to the most expensive plane in the Boeing lineup, the Boeing 777-9. Applications. Replacing conventional ship fleets with a faster, more eco-friendly alternative. Improving efficiency of commercial shipping-related transportation due to increased speed with similar payload capacity to a general cargo ship of around 15,000 deadweight tonnage. Replacing long-distance plane routes with a more cost-effective and eco-friendly alternative by not requiring paid-for fuel types like jet fuel, gas, diesel, etc. And it's a more cost-efficient alternative in all markets due to the independence from conventional fuels. This especially applies because gas prices often spike, as can be seen in the gas crisis of 1970 to 1980, and currently due to the pandemic and Ukraine war. Analysis. Vehicle comparison. I'm comparing the SA-15 class icebreaker to a pond skipper. They both have a similar cargo capacity, as the SA-15 has 19,200 meters cubed of cargo space, while the pond skipper is 19,600 meters cubed of cargo space. The SA-15 has a top speed of 17 knots, while the pond skipper has a top speed of 170. The SA-15 class has a range of 30,000 kilometers, while the pond skipper has an unlimited range as long as there's water. The SA-15 has a crew complement of 42, while the pond skipper has a crew complement of 3. The SA-15 class uses heavy fuel oil, while the pond skipper uses water. The SA-15 has a consumption rate of 76 tons of heavy fuel oil per day while underway, while the pond skippers currently can't be calculated. The cost for fuel per day while underway for the SA-15 class is $55,000, while the pond skippers is $0. The cost for crew per day is $2,186, assuming they receive the lowest annual wage, while the pond skipper has a crew cost of $608 per day based on the average pilot annual wage. The cost for a ship, the SA-15 class, is $133 million, while the pond skipper is around $445 million. Conclusion. In conclusion, the pond skipper has the potential to change the transportation industry. With the right financial and public support, the pond skipper could be an effective competition for the main pillars of transportation: automobiles, trains, planes, and ships. Despite the high cost to build this vehicle, its high payload capacity, high speed, and zero carbon emissions are desirable features. Government incentives supporting innovations that combat climate change will also help to make this vehicle a viable option for the transportation industry. Here are my sources of error. They include not knowing the power output of the reactor, not knowing if the plasma reactor even works in the first place, labor and electronics cost, lack of public information related to costs, and the challenge of heating and containing plasma is still largely unresolved, which relates back to not knowing if the plasma reactor works.